Hello, this is Dr. Paul Cottrell, and I'm doing a recording on September 7th. This will be shown on all my channels, so please subscribe to all my channels. I have 4 channels on YouTube, Brighteon, Bitchute, and Rumble. You can also follow me on X and GETTR. All the links are in the description of this video and all my videos. You can also watch live streams, including on my website, the-studio-reykjavik.com, and listen to previous podcasts in the audio format on Podomatic, Apple Podcast, and my website, the-studio-reykjavik.com. I've also set up a Substack channel, so if you like to help support my work, you can join my Substack. All the videos I do are for free. I have nothing out there covering the news that's behind a paywall, so you can get my videos for free anywhere. But please help support the work by sharing the links, subscribing to the channels, asking your social media to follow me. And if you would like, get the great products that I have on my store, the-studio-reykjavik.com, and donate. You can donate through Stripe, PayPal, or buy me a coffee on my website. You can be a paid member to my Patreon channel, and you can be a paid member to my Substack channel. So please help support the work that I do. All these videos I do are for free to help to inform you about my perspective of some of the things that are going on in the news. All right, so what we're going to do is cover some of the latest research that has been published about COVID. All right, the COVID era, let's put it that way, the COVID era. And then we're going to start listening to some of the videos that have been recently published about new cases as we're moving into the fall and winter season in the United States. Cases are surging, all right, but should we be alarmed? No, but we should be prepared. So with that said, let's talk about the 2 research studies that have been showing a little bit more light on what's been going on during the COVID era. One research study shows higher incidences of cancers relative to the uninoculated group versus the inoculated group. So the inoculated group had more incidences of cancers relative to the uninoculated or non-inoculated group, So I'm using the word inoculated because of the censorship. All right, so you have a group of people that have been inoculated during the COVID era having higher instances of cancers relative to the non-inoculated group. All right, so that basically means that the ones that have had more boosters are adding to the probability of getting cancers and accelerated cancers. Now, why is that? All right. Now, that ties into the second research publication that came out about what's in the messenger RNA vials. Well, there's a lot of debris. There's a lot of debris of segmented DNA or fragments of DNA, plasmids, the SV40 plasmid. There are other debris that aren't just the lipid nanoparticle or the messenger RNA. So you have this debris field in the messenger RNA of Moderna and Pfizer. It's not just a Pfizer issue. So if you have especially lots of plasmids, SV40 plasmids, you're increasing the chances of genomic integration. So if you're increasing the chances of more genomic integration, then you're going to end up perturbing the cell that will potentially lead to a cancerous pathway. You could be shutting down tumor suppressor genes, maybe upregulating oncogenes, be overproducing the S1 and S2 subunits, which are tumor suppressor inhibitors. especially for P53. So you have data that's coming out now that is showing that the inoculated group has higher incidences versus the non-inoculated group. Now, it's really important to keep in mind here that that harm through the inoculation program definitely happened. There's a short-term and long-term injury of it, all right? But there's also harm that is caused by the pathogen, SARS-CoV-2. And again, it's short-term and long-term. You have to look at these in different categories: natural infection, inoculation, long-term, short-term effects. All right. So if we take a look at the inoculation, some of the short-term effects were transient immuno issues, immunosystem issues, such as a reduction of your CD4 count, let's say. But other patients had a autoimmune issue. So it was it upregulated antibodies. So you had in some people lower immune system. You had some people that had higher immune system activity, but that was transient. That's what I mean short term. You also had in the short term aspect where they might have had some issues with clotting, right? And then it went away with treatment or just time. Then you may have had individuals that had down the road more problematic issues with cardiovascular issues or myocarditis, right? So there was this transient effect, and then there was this more long-term effect for certain patients. Now, in some patients, you could have short-term effects go away, and then a long-term effect that pops up. In some patients, it's only the short-term effects. I'm talking about the inoculation group. And then it goes away, and then there's no long-term effects. And there are other cases where you may have no short-term effects and then long-term effects. So there's these different categories of people. So it's not, this is what I've been saying for 5 years. It's not cookie cutter. It's not, oh, if you get an inoculation, this is definitely going to happen to you. No, probabilities are increasing, especially if you do more than one shot. All right. You know, if you do multiple boosters, you're increasing your chances. All right. So it's a probability of what could happen with one shot, one inoculation. And then it's additive. The probability of having some sort of adverse reaction, short-term or long-term, increases each shot. Now, it's debatable of what's the additive probability. Is it an increasing additive probability, or is it slightly less than? What I mean by that is that let's say you have a 10% chance of having an adverse reaction to an inoculation, and you have a second shot. Is it 10% plus 10%, or is it 10% plus 20%, or 30%? So it's definitely additive. But the question is, what is the additional probability of an adverse reaction, short-term or long-term, when you have an additional shot? I've been conservative to stay on the path that it's the same. So it's 10% plus 10% plus 10% plus 10%. But there is a case to suggest that maybe it's 10% plus 20% plus 30% as you move to more shots. There are many people that have had 3 boosters or 4 boosters and bivalent and all that, you know. So having more increases your chances. The question is what is that incremental increase? Is it the same as pre-4 or less? Who knows? Who knows? But I think that it's safe to assume that it's the same probability for each shot, and it's just an additive probability. But the key point here is that the more shots you have, the more you're increasing your chances for either short-term and or long-term effects. Why? Because of these debris fields that are in the vial. All right. When you have, well, there's two issues to this. You actually have the debris field, and it can't be filtered out properly. And you have a spike that has been designed in the laboratory for the natural pathogen, but the S1 and S2 subunit attaches to multiple receptors that have multiple pathologies. So it's not as simple as, oh, just have an S1 and S2 subunit and create antibodies for it, because you're creating spikes. And some of those spikes are leaking out, they're shedding out of those cells and going to other cells on top of eliciting an immune response. So you're getting some pathology off of the spike, all right, and causing an inflammatory response, especially at the vascular level, leading to these strange clotting issues. So you have that part of it, is the S1, S2 subunit. Then you have the messenger RNA that's producing too much of this stuff, and it's not being degraded as fast as it was thought. And you can have genomic integration of the messenger RNA. It could break up a little bit, there's a reverse transcription, and it can get inserted into the genome, which is something that most people didn't realize, and how easy it was to actually have this swapping of DNA. In addition, you have these plasmids in the vial that add to the probability of genomic integration, producing more messenger RNA than just what's packaged in the lipid nanoparticle. So you're producing even more of this S1, S2 subunit, and leading to more of the pathologies that I just recently mentioned, especially clotting. So if you're producing all this inflammatory response, you're going to have problems and damage to tissues. In addition, the S1 subunit attaches to the TCR, the T cell receptor. This is what I was talking about, where the immune system is going down. Well, if you block the T cell from attaching to the MHC, so the antigen presenting, the APC, the antigen presenting cell, has an MHC2. Well, it's presenting pieces of the S1, S2 subunit, and it's trying to get an elicitation from the immune system to produce antibodies. But if you have a lot of S1 produced because of the plasmids and the messenger RNA not degrading as much, and genomic integration or whatever, you have lots of this S1 leaking out into the interstitium. And when you have that, then it's attaching to the TCR that's on the CD4. Well, when it's attaching to this TCR, it's preventing the T cell from actually being properly activated by the APC. So what happens is that S1 subunit is on the TCR, and it's producing pro-inflammatory cytokines profile. So it's lots of inflammation, but you have an effective CD4 count that's lower. This is exactly what I've been saying is an element of the AIDS-like syndrome. Effective CD4 count doesn't work. Now that can be long-term or short-term. Short-term would be, all right, you have a lot of this S1 floating around because of the inoculation, or even the infection, natural infection, because you have lots of viron, right? And it's blocking the TCR. Okay, so you have lots of inflammation, but the immune system isn't reacting. So if it's slowly, eventually over time, you get some TCRs that aren't blocked, and it starts to elicit an immune response. So there's this lag effect. All right, that's at the short term. So you have this lots of S1 subunit, and effective CD4 counts are lower. And then over time, there's enough TCRs that are coming into this inflamed area that it's not blocked, and eventually, slowly, it's starting to elicit an immune response and trying to fight it off. All right. So you have this short effect. Now, if you have genomic integration, I'll give you two examples. If you have the genomic integration with it not being integrated in an immune progenitor cell, but just, let's say, a regular cell, a regular somatic cell, then you'll have this production of this S1 and S2 subunit. And if that gene is expressed, it's producing these, it'll get leaked out and then start to affect the TCR. And then over time, if that expression is turned off, over time, it starts to degrade, and then your CD4 count will come back up. Effective CD4 count. Your total CD4 count seems normal, but it's blocked because of the S1 subunit. So it will come back to normal levels as the production of the S1 subunit starts to stop. So if you have certain cells that have the genomic integration that's turning on this S1 subunit and or the S1, S2 subunit, but the S1 is the one that I'm more focused on right now, then what's going to happen is that there's that expression, then your effective CD4 count is coming down. If the gene expression is turned off and eventually the S1 subunits are degraded, then your effective CD4 count starts to go back up. So with this age-like syndrome, you'll see this undulation that's taking place. Oh, your immune system's okay, and then all of a sudden your immune system's not. That's with genomic integration without a progenitor immune cell. Now let's say that you go in and then you have a genetic mutation of this, let's say the plasmid came in from the inoculation or genomic integration from the natural infection. Doesn't matter. It's the same effect. So it gets into the progenitor cell, and now anything coming after the progenitor cell is going to have this genomic integration and problems with its immune cell. All right. So now you have genomic integration. There's different types of genomic integration. You can have genomic integration in the progenitor cell that's producing the S1 subunit. So now it's coming in, it's becoming an immune cell. It's very hyperactive. It's producing lots of S1 subunits, leaking out in the interstitium. It's leaking out into the extracellular matrix, and it's turning off other TC4s because the S1 subunit is attached to the TCR. Okay, so now what if you have a genomic integration that's actually affecting the way the antibodies are recombining to be able to produce the antibodies? All right, your early immune cells do recombination. Well, if you affect some of these important cells that are in your lymph nodes or in your bone, then you're going to not be able to fight infections because it's affected the recombination. So you have that problem. Again, AIDS-like syndrome. Now, if you have that problem and it's long-lasting, your body is going to have a harder time to fight cancers. So you have a cancer problem partially because of the genomic integration with the progenitor cells and not being able to recombinate. You also have a problem because you have genomic integration in progenitor cells and or other somatic cells that are non-immune immune cells. Well, you have S1 subunit going into the interstitium and shutting off the CD4s because the S1 is attaching to the TCR, preventing it from attaching to the MHC to elicit an immune response. So depending on where the genomic integration is and what kind of genomic integration it is, leads to these pathologies. So it's not cookie cutter. The pathologies are different. The situations are different. there is a complexity here that most people are not paying attention to. So the two research papers that came out recently about cancer incidence going up because of ones that are inoculated versus the non-inoculated, and the ones that the other research paper is showing that there's a lot of debris in the vials, DNA debris, high concentrations of plasmid, problems with the lipid nanoparticle, and other and messenger RNA not being packaged properly with the lipid nanoparticle. There's lots of debris there, so it's causing inflammation. It's causing a disruption. If you have pieces of RNA or DNA that gets into the cell, guess what? If you have a complementary, if it has a complementary code with another, let's say another RNA, you can shut off processes. So you can have this debris attached to a code that's in the cytoplasm of the cell, and that code is supposed to be a tumor inhibitor. Well, if you have code that inhibits a tumor inhibitor, if you're inhibiting a tumor inhibitor, you're adding to the chances of having cancers. So part of this cancer problem is the genomic integration, not being able to elicit the immune system properly. The debris code attaching and silencing tumor suppressors. Now, you can also have the S1 and S2 subunit silencing tumor suppressor proteins. So you can silence the code of the RNA, and you can silence the actual tumor suppressor protein. All right, so this is part of the reason why this is happening, but it's important to understand it's happening in both the natural infection and the ones that have been inoculated. So we step back and go, it's like, well, wait, that's a lot of information, Paul. I've been saying this for 5 years, honestly. So there's nothing new here. To me, this is nothing new. I've been saying this for 5 years, that this was going to happen. And I'm adding another aspect to this. Dementia is coming. And I'll be talking about that shortly in this video. All right, so with the inoculation, you have this genomic integration problem by the messenger RNA or the plasmids and the plasmids. You have integration at different types of cells, progenitor cells. So the higher upstream you are with the integration, the more of a problem it may be for the immune system and your blood cells, right? Your other even red blood cells. All right. So it depends on where it's up on the upstream for the genomic integration. If it gets genomically integrated in something that's a little bit more downstream, it's shorter. It's a shorter effect because those cells eventually die off. But upstream effects, they're more longer lasting. Maybe in some cases more permanent if it's the hematopoietic stem cell. If you get an integration there, boom, it's done. That's permanent. So you have these, where it gets integrated depends on how long lasting it may be in terms of the immune system. Now, let's say that it's a genomic integration of a somatic cell that stays around for a long time. Well, if it's genomically integrated in a somatic cell and is sitting there and it produces, it's going through gene expression of this integration, it's going to be producing this S1 and S2 subunit. We're talking about the genomic integration from the inoculation. And so every time it's doing that, if it's overexpressing and it's leaking into the interstitium, it's going to shut down localized CD4s and affect other cells, and it's going to cause this inflammation. And when you have chronic inflammation in these tissues, it can elicit changes in the genomes of these surrounding cells that could lead to cancer. So if it's chronic, then you're talking about a problem where, boom, cancers are starting to happen. So you have this overexpression, more of a shutting down of the CD4 and you have pro-inflammation, chronic inflammation that's taking place. You can also have this integration in cells that are maybe have one of the 5 knockouts for cancer. And because it's producing the S1 subunit in these somatic cells that are moving towards cancer, that because of the S1 and S2 subunit is shutting down tumor suppressor proteins, then you're increasing the chances of that cell moving towards full-blown cancer. Because you have these cells that are kind of precancerous at the genomic level. And over time, it can become cancerous. So if you have this genomic integration in these cells, you can speed up the cancer. And the weird aspect to this is that if you have these genomic expressions, if you have these genes that are being expressed for the S1 subunit, it's shutting down the CD4s that are trying to elicit an immune response to kill the cancer. Again, AIDS-like syndrome. So AIDS-like syndrome is happening, especially for the inoculation. And again, the more inoculations that you have, the higher the chances this is happening. But again, it depends. There's a short-term effect and a long-term effect. And it doesn't necessarily mean that if you've had shots, it does not necessarily mean that you have the genomic integration. You may have it, you may not. You may have it and it's not expressed. You may have it and it's heavily expressed. So there's different populations, all right? It's not, oh, if you get it, you definitely will have the genomic integration. No, that's not necessarily true. And again, depending on what kind of cells it gets integrated, if there are cells that are easily recycled or they have a short half-life, let's put it that way. If those have been genomically integrated, they'll die off, and then you have the short-term effect, and then all of a sudden you have no long-term effect. So I just explained why some people have a long-term effect and no short-term effect, and some people have just short-term effect, no long-term effect, and some people have both, and there's some people have nothing. And if you follow the whole logic of what I just said, that explains the whole landscape of the ones that are inoculated. Now, the ones that have the natural infection has multiple proteins, has lots of SNPs, like SMP5 and SMP8. These are tumor suppressor inhibitors. These SNPs also increase different types of gene expression. It can increase the methylation or decrease the methylation. And when you're turning off genes through higher methylation, because these NSPs affect the methylation of genes. So if you're affecting the methylation of genes and it's increasing methylation, and you're turning off a tumor suppressor, if you're methylating a tumor suppressor, voila, you have cancers. If you are increasing the acetylation or decreasing the methylation of an oncogene, guess what? You have a situation where the cell can go cancerous. And that's through the NSPs. On top of the S1 and S2 subunit, because of the spike within the natural infection, turning off the tumor suppressor proteins, and turning off the TCR, inhibiting the TCR on the CD4. So your effective CD4 counts go down. So your effective CD4 counts go down because of the inoculation or the natural infection. Now, when you eventually clear the infection, and there's no more production of the S1 and S2 subunit, or the other proteins that make up the viron, then you go back to homeostasis. But what if you have genomic integration? What if you have a dormant set of viron in, let's say, your macrophages, M0 macrophages, or in adipose tissue? And you're fine. You get no problem, and then all of a sudden it rears its head up again because it's expressed. these M0 macrophages start to become activated, and boom, there's a production of viron, and then boom, it starts to produce lots of S1, S2 subunit, affects the CD4s by inhibiting the TCR, produces more proteins that are tumor suppressors, or affects the methylation of the cells that's infecting. See? So then you can also have genomic integration. So there you both. Don't fall into the fallacy. Don't fall into the trap, the thinking that it's just the infection. It's just the natural infection. It's just SARS-CoV-2. It's not just SARS-CoV-2. But don't also fall into the trap that you're thinking it's only the inoculation. It's both. That's the problem. And this is why I kept on saying there's no solution for this. You can't get away from this. You pick your poison either way. And there's short-term and long-term effects. Now the question is, if someone, and it's a good question when someone says, which one is the worst case? Probably the worst case is genomic integration of cells that have long half-lives by the inoculation group because of the plasmids. Because in the laboratory, when you want to manipulate cells, if you want to elicit cancers, you use plasmids. So, but you can also use viral vectors too. Not just plasmids. You can use viral vectors. And so the natural infection would be the viral vector to elicit, let's say, cancers in the laboratory. But you can use plasmids too. But I suspect that higher incidences of genomic integration because of the high concentrations of the plasmids. But the genomic integration can happen with the plasmid. The genomic integration can happen with the messenger RNA getting truncated at a certain way and going through a reverse transcription. The genomic integration can happen by the natural infection. And that genome gets reverse transcribed and integrated into our body. Now, this is super dangerous stuff. That it was designed, this is not like a normal virus. It was designed to have different pathologies. It's not something that would have emerged from nature. This has been developed. So it has different pathologies. So every time you get an infection and there's mutations and it affects different types of tissues, have different affinities to different receptors, it's going to produce different pathologies, especially at the short term, as it hones in on different receptors, as that affinity changes. Long-term effects, we're not really sure because this is emerging. This is an emerging behavior. But don't fall into the trap that it's just the virus or it's just the vaccine, because it's not. It's both. It's both. Now, it doesn't mean it's equally weighted for the different landscape of different patients. There's a patient landscape that. So it's a complex, multifactorial problem. Now, is it true that higher incidence of cancers between the inoculated group and the inoculated group? The higher incidence of cancer between the inoculated group or the non-inoculated group? Yes. Yes. But it's also true that cancers are increasing between non-inoculated and non-infected by the natural pathogen versus ones that are non-inoculated that have been affected. So when people say, well, there were no, the deaths were coming from just the vaccine groups. Especially, well, no, there were deaths that were happening before the vaccine was even available. And even before the antivirals were available. So obviously, at the short term, there were deaths in the first wave that didn't have the antiviral therapeutics and didn't have the vaccine. So explain that, because the virus does kill. Now, were there adverse effects that led to death because of the inoculation? Yes, absolutely. And not only that, they were trying to hide it. They had two different VIR groups. They had a VIR database for the public, and then there was a secret one. They were hiding the vaccine injury. Now, again, 5 years ago, I was saying, guess what? There is an aspect to the power of numbers. If you're publishing, now they lied about the publishing, but let's just go with the logic I had at the time. If you have, out of 30,000 people, 100 adverse reactions that led to death, all right? That's a relatively small number, 100 divided by 30,000. Compared to, let's say, 350 million. The number, that power of number, you start seeing that 100 ballooning out, starts getting worse. And it's not linear. It's most likely there is a higher magnitude that the sampling didn't catch during the clinical trial, on top of them lying. So the numbers were even higher. So the adverse effects from the vaccine were much higher because they were lying. They were lying. But the thing is that there were people that died that didn't have the antivirals and did not have the vaccine, and they had SARS-CoV-2. So now people would say, why isn't there so many people dying now? It must have been, some sort of lie or whatever. Because most of the people in the population, and all you can do is do a simple blood test and you'll know, most of the people in the population have antibodies, either natural antibodies, shedded antibodies. Let me break this down. Natural infection and/or an inoculation. Most people have been inoculated. Or you've been exposed to elements of the shedding of the S1 subunit from people that have been inoculated, or the elements of the shedding of the viron that led to an immune response for you. So most people, even if you don't think you've had SARS-CoV-2, you have antibodies. You don't believe me? Take a blood test. Find out if you have antibodies for SARS-CoV-2. Look for M, look for E, look for S. You can even test to see if you have the epitope from the inoculation. So if you have the epitope, if you have an antibody that would have been elicited by an inoculation, but you did not get an inoculation, right there shows that you were exposed to a shed. Most people have antibodies, and therefore there is a herd effect. There's enough antibodies out there in the population that controls the spread, that prevents severe disease. But because there are so many people that have a similar epitope, the same epitope from the inoculation, there's selective pressure for the virus to find a new attachment zone, a higher affinity to the multiple receptors that it attaches to. And over time, it will emerge as something different. The pathologies will be different. And what I call the pinball effect. And I've said this 5 years ago. Everything I said is happening. Everything. Now, what is also interesting, back in the early days of SARS-CoV-2, 2020, I probably said this in maybe April, maybe March, probably April, maybe it was March. And knowing that it attached to so many different receptors and knowing the comorbidities of the United States population, I stated that within an 18-month period that there would be about 6 million people that would die, all right, in the United States. It ended up 6.5 million or so worldwide died from it. But what is interesting is that at the time of my and obviously it was more than 1 million that died in the United States. But at that time, I was saying about 6 million, 6.5 million would die in the United States, and 65 million would die worldwide. All right. Now, what is interesting here is at that time, I didn't fully appreciate the adverse side effects of the vaccines. So, long term, we had more than 6 million deaths because of the COVID era. Now, it wasn't through the virus. It was through the virus and the vaccine. And that led to a much higher number. That's not readily available to be able to see how many deaths actually happened because of the virus and or the vaccines. Now, also at the time, when I made the statement about the 6 million people in the United States dying within 18 months, I didn't fully appreciate that people that were on diabetic medication ended up having a protective layer from it. Now, all of a sudden, you hear in the news about the GLP-1s. I'd have to think about this a little bit more, but I would not be surprised that this big push for the GLP-1 medications is producing a biolayer, a bioshield, to reduce the chances of further, how do I want to phrase this? At the societal level, it's going to reduce the spread and the severity of SARS-CoV-2. People that were diabetic, that were on medication, they were somewhat protected by it. It wasn't as severe. But the going thought at the time, early March of 2020 or April of 2020, was that ones that were diabetic had the comorbidities and that they would succumb to it quicker. And that wasn't the case, because it was actually part of the mechanism to protect is to have these blockers for certain receptors that are tied to diabetes. So those are some of the lessons learned from it. But there is an inoculation issue and there is a viral issue for cancer, for the immune system, for syndromes like long COVID. Your system, you can have autoimmune disease that is a little bit more, let's say, short-term or transient, or more long-lasting. Same thing with AIDS-like syndrome. It could be short-term, where you have an effective CD4 count that's down, and then it clears, and then you're back to normal. It could be transient. It may rear its head again, and the CD4 count effective goes down again. Or it can be longer lasting. And it depends on where the genomic integration is. Is it upstream? What kind of cells? How many times have you been boosted? How many are you getting a resurgence of? Are you getting another hit by the virus? Is it dormant and then it rears its head? Because it's dormant. You can't get rid of SARS-CoV-2. Once you get SARS-CoV-2, you can't get rid of it. It stays in your body. It's dormant. The virons are dormant in certain tissues. Now, most people don't know that, but it stays dormant. And that's just with the viron. because it can be in the adipose tissue, it can be in the gut, it can be in the colon tissues, it can be in the M0 macrophages, but not just that. You can have genomic integration. You can have a situation where a patient has the full genome or many parts of the genome, but it can happen where you have the full genome of the virus in your cell. Now, if that cell doesn't die off, and let's say it divides and you have more of those cells, and it expresses, you can express the virus. So what we're going to do now is do a cursory review of the news based on what is being published about SARS-CoV-2, new cases in the United States, what's really going on. Now, my personal take on this is that the fall and the winter season will be problematic in terms of new cases. But that doesn't mean it's going to be like the first wave, the second wave, or even the third wave that we went through during the COVID years, all right? So we have, it's endemic. You can't get rid of it. Once it's in your body, in many people, it stays dormant. It can be genomically integrated. It can stay in macrophages. It can stay in adipose tissue. Guess what? You can't get rid of it, even if you are asymptomatic, all right? Secondly, it's endemic in the society. So it's going to be moving around, and sometimes it flares up, sometimes it's not. We're in that flare-up phase. Most likely this fall and this winter, you're going to have more cases. Now, most people, it's going to be flu-like symptoms, but many of the cases, especially the ones that have nimbus, have they have throat irritation much worse than previous infections. Why? Because it's mutated in such a way where it's attaching to the epithelial lining in the upper respiratory area, especially in the oropharynx. This is the reason why it's so important to be vigilant and to be prepared. I've told you in multiple videos what you need to do. I can't say it in this video because it'll have a strike from YouTube. So it's really important to pay attention to some of my other videos. But it's in an endemic phase, and we're going to have these ups and downs in terms of number of cases year over year. The problem is that when you do get exposed, you are pulsing your immune system. It gets a reaction. It's going to, because most people have antibodies, it's going to be controlled and the severity will be less because the antibodies are controlling the infection and reducing the severity and clearing your system quicker. But there's an inflammatory response in the production of the S1, S2 subunit as the virus multiplies in these cells. As that's happening, the S1 subunit that can shed from the cells, or even just the S1 subunit on the virus, can attach to the TCR of the CD4 cells. So your effective CD4 count could go down in some cases as you have this viral infection. So it slows down the response time for the immune system. And in addition, when you get this pulse from the endemic phases, it's also creating this pro-inflammatory cytokine. If it does elicit a response from your immune system eventually, then what will happen is it's going to upregulate IgG4s, and the IgG4s are going to go up and become immunosuppressive. So that is another issue with the inoculation. Constantly getting inoculations keeps on making, one, your titer levels less responsive. Your max titer levels after inoculation is less responsive. And you are increasing the levels of IgG4, which is a feedback loop, a negative feedback loop to suppress the immune system. Right? So you get this IgG4 hit through overboosting and also this overpulsing with this natural infection. So this is something that you got to kind of pay attention to. The whole reason why the IgG, not the whole reason, but a big reason is to prevent the immune system from overproducing. So it's important to have that negative feedback loop. But if that negative feedback loop is over expressed, then, or the robustness is too much, then it's actually going to be immunosuppressive. Hence, again, another mechanism for AIDS-like syndrome. So it's really important to keep this in mind. That these two studies that just came out, that the inoculations have debris that were not filtered out that cause harm. This was known in vaccine manufacturing for decades. So this is nothing new. The only thing new about it is that they were using a messenger RNA platform, and there's a higher concentrations of plasmids. So obviously there's going to be more vaccine injury. But it's also overexpressing something that has been finely tuned to be a bioweapon. That's the S1 and S2 subunits. So it's expressing something that went through serial passage to hit multiple targets. And when you hit multiple targets, you have multiple pathologies. And not only that, over time, you're going to have an evolutionary process where it starts to gain affinity to these different receptors. So the pathologies are going to change over time. And this is what I mean by the pinball effect. And you have the S1 subunit in the inoculation, and you have it in the virus. So you can't get away from this. It stays in the body, but it also is floating around endemically in the society. You can't run away from it. But again, if you have antibodies, it does, in the aggregate, show that severity is much less than before. But that does not mean that an emergent property won't happen. Most likely it will happen because there were so many people that were inoculated with the same epitope. And so it's a major problem. And people need to just pay attention. Will this wave kill lots of people? No. Could this wave cause higher incidences of cancer 3 or 4 years down the road? Yes. Could it cause dementia, higher levels of dementia? Yes. Now, let's switch the topic about the dementia route. Okay. So with dementia, higher incidences of dementia are going to happen within the next 5 years, especially people that are 40 years of age or older. Okay. And there are different categories. Part of it is poor health choices and environmental exposure. For example, nanoplastics and microplastics accumulate in the brain and cause early onset of dementia. Also, microplastics and nanoplastics accumulate in the kidney, the liver, the heart. So you're going to have problems. You can't get rid of it. Nanoplastics and microplastics, no one has figured out a way to get rid of it. But there's definitely a correlation with higher incidences of early onset of dementia and concentrations of nanoplastics and microplastics. So environment is part of the cause. Chemical exposure, environmental exposure is a big part of that. Then you have amyloidosis. And amyloidosis has different categories. And amyloidosis is basically you have misfolding of protein, amyloid protein, and what happens is that could cause tissue damage. Now, if we're talking about neuron, because amyloidosis can happen in different organ systems, not just the brain. So when you have that accumulation of amyloidosis, amyloid plaque, then you will have cognitive decline. Now, what is interesting is that certain amyloid plaque buildup, sometimes it's a misfolding. That what happens is there's a misfolding of the protein. It can't be broken apart because of the beta sheets. You have alpha and beta parts of the protein. So you have the beta sheets can bind together and prevent the ability to break up the protein. So different types of plaque, different types of amyloidosis have different layers or different structure of the protein. Some have maybe a 2 beta sheet sandwich, or a 3 beta sheet, a 5 beta sheet. The more the beta sheets, the harder it is to break up. So some amyloidosis isn't as severe as other amyloidosis because of this accumulation of beta sheets. This also is part of the tau and amyloid plaque buildup for Alzheimer's. And then you have another part that another subset of amyloidosis that is actually prion. Now, the prion is a misfolded protein that will start to build up and build up and build up and not break apart. And another feature of it is usually it kills off the patient quickly. But there are very, very rare prion diseases that actually could last, that take 10 years or 15 years to kill the patient. So you have some subcategories of prion. So it's important to look at it from the standpoint there are these different categories. You have early onset of dementia because of chemical exposure, all right, affecting the neurodegeneration. You have some sort of vascular issue where it's ischemic, and you have ischemic or hemorrhagic. So ischemic means less blood flow. Maybe the blood vessels are constrained too much, or you may have leaky. The system may be leaky, and it's hemorrhaging, and there's lack of blood flow to that tissue in the brain, and it leads to neural death. So that's one category. Vascular. All right. Hemorrhaging or constriction of the blood vessels. The second category is the environmental exposure. The third category is the amyloid category. And that amyloid category has two main categories to it, two subcategories. Amyloidosis that is non-prion, and then amyloidosis that is prion. They're not all equally weighted, okay, in the context of the crisis. Okay, so environmental exposure that is not SARS-CoV-2 or let's say COVID era related. Let's carve that let's carve that out. Let's only look at what is happening in the post-COVID era that's related to COVID, either inoculation or natural infection. Lots of vascular problems leading to vessels, microvessels bleeding, leaking, or microvessels constricting, and having blood clots, micro blood clots. So when you have lots of these micro strokes, it'll end up being early onset of dementia. This is the far majority of the cases, 75% of the cases that end up being early onset of dementia. That doesn't mean everyone's going to get early onset of dementia, but if someone is getting early onset of dementia, the far majority of the cases, 75% of the cases, are going to be this. It's going to be vascular related. blood clotting, microstrokes, microbleeding, ischemic. The second category, which is the amyloidosis. Again, the amyloidosis is building up a plaque that is having a hard time getting broken up through proteolytic enzymes or can't be broken up. And depending on the number of beta sheets, the more beta sheets, the harder it is. That's stacking. Now, another 20, roughly about 24%, let's go 24%. So 75% of the early onset of dementia that's related to SARS-CoV-2 or the COVID era, let's put it that way, will be 75% of those will be vascular related for early onset of dementia. 24% is going to be amyloidosis, but non-prion. 1% or less will be prion related. So you have to keep this, that we see the incidences of cancers going up in the post-COVID era. You're seeing immune system problems and different syndromes popping up, but there's going to be another aspect to the pathology of the COVID era, and that's going to be early onset of dementia. So it's important for you to protect your neurons. Now, how does this happen with the amyloid? People will ask, well, like, okay, you understand that the vascular problem, either microbleeding because of the weakness of the vascular wall because of inflammation. There's leaking there. There's these microclots because of the pro-inflammatory cascade and the S1 S2 subunit from the virus or the inoculation leads to these really strange clots, and could lead to this micro death of the tissue slowly, and it gets worse and worse over time. Okay, you have that. Now the amyloidosis. Well, you can create inflammation at the neural level or around the neuron, and that will perturb the actual building up of the proteins. So if you have high stress and high inflammation with these neurons, you're increasing the chances of misfolding. When you increases the chances of misfolding, eventually you're going to have this buildup of this plaque, these amyloidosis, and shutting down of the proteolytic enzymes that help to break up misfolded proteins. So the cellular mechanism to break up the protein is hijacked by the S1 S2 subunit. So you have this happening with the inoculation and with the virus. Now, there's some other complications with the virus because it has more proteins, it has more chances of shutting down the proteolytic enzymes. It kind of hijacks the mechanism to prevent the cell, the neuron, to clear it. All right, so proteolytic enzymes are hijacked. Now, with the inoculation, you have plasmids and you have this DNA debris and you have the messenger RNA and the lipid nanoparticle. These are causing inflammation, leading to misfolding. You have the S1 and S2 subunit being overproduced that can lead to shutting down the proteolytic enzymes and creates this stress in the cell, in the neuron, that leads to misfolding. Now, some people would say, well, there's also motifs within the S1, S2 subunit that may cause amyloidosis. Well, we have a lot of motifs in the P53 protein that's endogenous to our genome, but it doesn't end up making amyloidosis. So just because it has a motif doesn't mean that it's going to make it. So So the way I see this is that it's stress in the cell that leads to misfolding and shutting down of the normal proteolytic process to break up these misfolded proteins. And then as they build up, because they have these beta sheets, over time it gets worse and it starts killing off the neuron. And it starts to get into the interstitium and it starts to gum up other neurons and other neural networks. And then you start to have this breakdown of the connection and you start to have the neural death because of the amyloidosis. Now, the prion issue is a small percentage. Now, if it's in its purest form with prion, you should be able to take the tissue that is diseased, that has the prion in it, in a patient that, say, passed away, take it out and be able to infect another person with it. Prions have an infective feature to create other prions. All right. So the data is so scant that the probability that this is a major feature of the early onset of dementia is less than 1%. So it's important to keep in mind that you have these different pathologies and different ways that the early onset of dementia could happen. Vascular, amyloidosis, where it leads to misfolding of protein and a buildup of plaque, and then very small percentage of prion. So people that think, oh, if you have early onset of dementia or some sort of neurological dysfunction, that it has to be prion. No, that's not. That's not the way to see this. It's like it's all about these probabilities. What's the probability of it being vascular? Okay, if it's not vascular and there's some sort of amyloidosis, right? Then, okay, is it infective? Is it contagious? Prions are contagious. So in its purest form. So if you have stress and you have other areas in the autopsy that's showing this amyloidosis, it's most likely not prion disease. All right, but you can determine if it's prion disease by taking the amyloidosis and trying to infect someone another set of tissue. And if you have this, if there's an infective property to it, then there's prion. That's prion. But we don't have that. It's a very low probability. There are some cases that maybe be popping up, but we're talking very low probability. And you don't know for sure that prion disease that was developed by SARS-CoV-2 or the inoculation or something completely unrelated. The data is just not there to make any definitive statistical significance. But it can happen, and there's a small probability. The larger probability is ischemic. And there's a 25% probability where it's accelerating amyloidosis. All right, so it's either amyloidosis, non-prion, or ischemic. But it's happening. And so this is a reason why you got to pay attention. So you got the cancers, you have the different syndromes and the immune issues. And now you have another issue, early onset of dementia. But it's going to happen. It's going to happen. So if you keep on getting infected by SARS-CoV-2, then you're increasing your chances of having the early onset of dementia. If you keep on getting boosters, you're increasing your chances of early onset of dementia. So when someone says, oh, I think that pro-vax is great. Really? Well, you're increasing your chances of having problems with your immune system or cancers with early onset of dementia. And then you have the other side that says, oh, the virus is nothing to worry about with the virus. Don't don't get any, don't worry about that. Wrong. Because you can get early onset dementia, cancers. So there's no good solution here. And this is the reason why I keep on saying that we've been all painted into a corner, because we didn't prevent the national security state from developing things they should have never been developing. But now it's way beyond that now. We're way beyond it. Now we have to, the genie's out of the box. There's an arms race in biological warfare that's being promulgated between the United States and China and other nations. But the thing is that there's an arms race. Now, when there's an arms race, they're making more things that are lethal, and it increases the chances of a leak. It increases the chances of miscalculation in the usage. And it's going to be a major, this is like the early stages of the proliferation of nuclear weapons. What is the architecture? What is the foreign policy? What is our national security stance on how to manage biological warfare? As a deterrent, as a defensive system, and as an offensive system. And while everyone's so focused on, oh, how many cancers have gone up, for breast or colon cancers, between the vaccinated and the unvaccinated, you're missing the whole point. You are totally missing the point. Or ones that are focused on, well, we have a debris field in the vials for these inoculations, and it's causing these injuries, these what we call vaccine injuries. Yeah. But what are you going to do when you're in a biological warfare? See, it's way bigger than is a plasmid in a vial. It's way bigger than pro-vax versus anti-vax. This is much larger issue now, since the genie is out of the bottle and we are in biological warfare. So to get a better insight of what I'm talking about here, make sure you watch my series. It's a multiple video series that I'm developing. I have 2 videos out there already. It's called Biological Weapons in Foreign Policy. We are now moving into an era where we have to live with the realization that we are in a different era, and that we are not going to be going back to a pre-COVID day. And it may get worse. All right? Especially when you have the speed of evolutionary processes through in silico simulation with AI, leading to further targeting of different receptors to dial in lethality of these different viruses or different pathogens. So it's going to only get worse. So don't focus on just vax, anti-vax, virus, antivirus, the virus deniers, all right? You're totally missing the point. Totally missing the point. It's biological warfare, and we're in it already. We're in the early stages of the warfare. Now, what are you going to do? What are you going to do? What are you going to do? Are you going to hide under your bed and put a mask on? That ain't going to help. You're going to over-vaccinate? That's not going to help either. What are you going to do? And because you've been so focused on stupid stuff, you are painted into a corner and you're trapped and you can't get out. All right, so let's play the videos on the stuff that's been playing for COVID. I'm only going to play the recent stuff to get an idea of the cases, but There's two variants that we have to worry about, is the Nimbus variant and the Stratus variant.
Before we talk avid Big Ten blood drive ideas, let's get in the competitive spirit with the scavenger hunt. I worked all weekend on that. Save lives and help win your school $1 million. Okay, it's in your nature.
Health news. COVID cases are surging again in America. The highest numbers in California, with Texas not far behind. Most of those cases now due to a new mutation. And our medical expert, Dr. David Winter, joins us live from his office at Baylor Scott & White. And when you see new strains and hear about...
Now, it's important to understand that coverage based on the most of the antibodies that people have can mitigate the severity of the new variants. Now remember, our titers last for about 10 years. They peak at 5 years and they start to wane down, but we have memory cells that last for a long time. We have B cells and T cell memory. So don't buy into this idea that you need, because something mutated, that you need a booster. Don't buy into that. You don't want a booster. I'm telling you, you don't want the booster because you're increasing your chances of having the negative externalities. But not just that, you have memory cells to elicit an immune response. Now, the reason why the severity of SARS-CoV-2 is not as bad as the early wave is because most of the population has antibodies.
Numbers, Dr. Winter, how serious is it? How concerned should we be?
Yeah, it looks like it may be more contagious than previous strains. A little early to say for sure. And I worry it may be more serious also because hospitals are going up more rapidly than I've seen in a year or so now. So I worry about that. Symptoms that you look for: runny nose, sore throat, cough, shortness of breath. Similar symptoms you see with a common cold, with influenza, with even sometimes allergies. So when people call me with those symptoms, I say, you got to do a test. And I've got a test kit here to show. Pretty easy. You can get these at the pharmacy. They don't cost very much. Here's a swab. You go up one side the nose, go up the other side. Put it in this little tube here. Twirl it around 10 times. Then you got this little pad. You put a drop here, and in 10, 15 minutes, you have your answer. These tests are pretty reliable, Mark.
Okay, good to know that we have a way to test for it. But when it comes to getting this virus, is it still spread mostly through the air like we've seen in previous strains?
Yeah, that's the most common way it's spread. And in fact, I can tell you, in some counties in California, they're actually talking about putting masks back on people out there. That's the most common way it's spread. People are coughing and sneezing, stay away from them. But you could all...
Masks do not work for a multitude of reasons. One, people aren't wearing them correctly. People are not taking them off correctly. People are reusing them. Another reason is that masks are designed to prevent this, to prevent the individual, to try to prevent the individual from passing on a respiratory infection. It doesn't prevent you from getting the respiratory infection. So if you're fine and you're wearing a mask, you're really not doing much. You're not preventing it. Now people say, well, what about the N95 masks and blah, blah, blah. Really, you're really putting it on right. You really, if you touch a surface and you rub your eye, guess what? You got a problem. All right. Now, in clinic, what was amazing was that we had students in clinic contracting SARS-CoV-2 after the clinic, and we had masks, N95 masks, and shields, and gloves, and people were still getting it. So there was an added level. You can't stop this. You can't stop it. Nope, can't stop it. Now, if someone has it, one, you shouldn't be in public. But by having a mask, you're reducing the chances of you're reducing the chances of spreading, but you're not preventing from spreading it. But if you're next to someone that has it and you don't have it, and you have a mask on, Especially if they don't have a mask, it's not going to stop it. You're still going to get it. And let's say they do have a mask, it's reducing the chances of spreading it to you, but you still can get it. So masks don't prevent you from getting it. Masks are more used to prevent the spread from someone that actually has it. And this is the weird concept that a lot of people don't understand. And this goes back to something that's even more philosophical. The masses, in general, are stupid.
You'll get it from close touch, hugging, kissing, shaking somebody's hand, touching a doorknob when somebody who had COVID just touched it. So frequent hand washing is also important.
That's
I know vaccinations are in the news recently, especially with changed recommendations from the CDC, and that raises concerns about, all right, how do you protect yourself from it? But let's say you do get it. How do you treat yourself?
Yeah, there's a really good medicine, Paxlovid. Some people call it Paxlovid. It's been around for a while. 3 pills twice a day for 5 days works really, really good. There's another pill that's available, long name Molnupiravir. That works also. And if you get sick enough to go in the hospital, there's an IV medication, Bicluri. So we have some medications to treat it. But the idea, as you mentioned, Mark, is not to get it in the first place.
Well, one of the ways you do that is get vaccinated. And I know there are a lot of questions.
Now, just remember, I've been saying this for years. Monotherapy does not work very well for viruses because the virus will mutate away from the treatment. It will circumvent. You have to capture it with multiple ways, multiple different modalities or vectors to kind of box in the virus. So antivirals may seem to help, but they can lead, especially in mass. If a big population is getting it and there's heavy prescription of the monotherapy, you will eventually have mutations moving away from the actual efficacy of the monotherapy. Viruses need to be treated with multiple medications at the same time and attack different aspects to the virus. Either the fusion of the virus, either the replication of the virus, either the packaging of the virus, but you have to attack it in a three-pronged approach or more. The problem is that when you do that, the side effects are more. So there's not really any good, again, there's not a good solution. Now people would say, oh, maybe hydroxychloroquine or ivermectin, and I know of cases where it has helped, and I've known of cases that it has not helped. So it's mixed results. I've known cases that people had no problems with going through SARS-CoV-2 after being inoculated, and I've known people that have had problems going through SARS-CoV-2 being inoculated. I have seen people that were not inoculated and contracted SARS-CoV-2 and weathered it just fine. I've seen people that had SARS-CoV-2 that were not inoculated and died. So it's mixed. It's mixed. It's not so clear cut on what to do. Now, part of the reason is that it's not something that's just a zoonotic pathogen. It has been finely tuned to hit multiple receptors. So it's harder to treat. And the bioshield for it didn't work. What they thought messenger RNA is the bioshield, it didn't work because of the manufacturing process sucks. And this is proven by the debris field that's actually in the vial. That's causing a lot of other problems, what we call vaccine injury. There's no treatment for this. You just have to hope that your body weathers it the best that it can, knowing that you may get cancer, knowing that you may get early onset dementia. But hiding under your bed or hiding, on a yacht or hiding on an island isn't going to help you.
how well the previous vaccinations work against this current strain, and if those vaccines are even going to be widely available for everybody.
Yeah, the current vaccine does work very well for this. We already know that, and we've been told from studies that the new vaccine.
Here's the issue that people need to really pay attention to. Your titer levels last for 10 years. Your memory cells last for even longer. If you contract it when your titer levels are low, you will elicit your memory cells to produce more antibodies. You will elicit your plasma cells to produce more antibodies. Most people will fall in this category. You don't need another shot, especially if you have a natural infection. Because a natural infection, you're more broad spectrum in terms of antibodies, because you have antibodies for the spike, you have antibodies for the membrane protein, you have antibodies for some of the other proteins that are within the virus, like the NSPs. So there's zero reason to have that. Now, let's say you have newborns that are coming on board, right? You know, newborns that are happening, that they're going to be exposed to the natural infection if they're not vaccinated. Now, I don't recommend vaccination with the messenger RNA. I think it's a very poor system, especially because of its manufacturing process. Now, what that means is that people are going to be infected and have to weather the storm, and a natural process will have to be natural. There's going to be natural selection. Some people are going to be harmed long term by the natural infection. Some people will not. So vaccinating a kid for this, I don't think is the prudent thing to do, because you can bring on a short-term and or long-term vaccine injury effect on the child. But to think that you're going to get away from harming the child by just with the natural infection, that could happen too. A short-term or long-term serious effect on the child. Another thing that's interesting, going back to influenza. Influenza during there is a thought that, okay, influenza happened in the 1918, 1919s. Wilbur Wilson was sick, all right? Supposedly he had influenza. And a few months later, or several months later, he ended up having a stroke and died. But he really started declining after that bout of influenza. Now, he was older. Now, what is interesting is most of the people that died during that time period from influenza was this group that was around 20s to 35, maybe 18 to 35 or 40, somewhere in there. So it was the middle age group, not middle age, but that 20 to 40 range for adulthood. The ones that were young and the ones that were old didn't have the death tolls weren't as high. And the question is like, why was that? And the thought process is that they were exposed to something similar when they were younger, the older generation. So that would have been Wilson. So he didn't die from it when he caught influenza. Now you got to remember, that's back in the I think he contracted in 1920. But he really went downhill and he ended up having a stroke. Now think about this for a second here. There seems to be a correlation between a pathogen that is not well presented within the human population and leading to vascular issues, leading to problems where there's high levels of inflammation, leading to strokes and clotting. Now, we don't know for sure all of the details because medicine back then wasn't as robust as today. But there is this really weird aspect to Wilson's death, and it's tied to his bout with influenza. Another thing that's interesting is children's education. With the children that were born during the 3 waves of influenza, their educational attainment and their health were not as robust as ones that were born either before or after the event. So educational attainment, cognitive function, even cardiovascular issues increased. Cardiovascular issues increased, educational attainment went down, overall health went down, life expectancy went down with these with the ones that were born or in utero during the 3 waves of the Spanish flu. So those are data points to kind of like pay attention to. So wait a minute. Will we have higher autisms? Will we have more behavioral issues? Will we see more cardiovascular diseases because of the different waves that happened during the COVID years? And then you add in another layer of inoculation on top of that? And I think yes. I think yes. So would you want to inoculate a newborn? No. No. There's too much risk. But that doesn't mean that they're in all clear if they contract SARS-CoV-2. They may contract it, and it may cause problems. But children have a tendency to have a very robust immune system, and they kind of weather the storm better. So I think it's what I call the D-Day effect. It's, it's just kind of you have to push through and hope for the best, and there is a survival mechanism that happens, and the ones that weather the storm better than others, then in the long run, it perpetuates the humanity, and we overcome it. But to think that we're going to be able to just allopathically move our way out of this, I don't know if that's the case. I think in many ways we're making it worse.
And coming out shortly, that also will work. But the tricky part now is, can you get one? The leadership in the FDA has changed, and they're now saying that you get one if you're over 65 or younger than that.
Why would you want to get one if you already have antibodies in the memory cells? That's the issue that I have. None of these doctors keep on saying it. None of these doctors tell you that the titer levels stay there for 10 years. You max at 5, but you're still there and you elicit memory cells. So why would you have this problem? Why? Why do they keep on saying you have to have a vaccine? Now, some of it's dogma, some of it's because they're on the take with the insurance companies. Now, and they get a bonus if they issue if they issue more vaccines over their quota or whatever. Now he's saying, okay, go, if you're 65 years, if you're over 65 or you're younger and have some sort of chronic illness, maybe you want to get it. Well, they're saying, okay, this is the comorbidity perspective. If you have a comorbidity, then you may need to take a vaccine. Now, think about this for a second. If you have if you're concerned, and this is the nuance against the anti-vaxxers. This is the nuance against them. Anti-vaxxers say, well, there's going to be vaccine injury. True. But if you're a patient that has 5 years to live and you have a chronic illness, let's say congestive heart failure, do you care about the vaccine injury that may start to arise 5 or 10 years? Or are you more concerned with being able to weather a storm, a respiratory infection that may lead to earlier death because of the comorbidity with your heart? Oh, it's all about nuance. See? See? This is why I keep on saying the pro-vaxxers and the anti-vaxxers they're both wrong. They're both wrong. It depends on the patient's situation. What's the long-term and short-term benefits? What's the long-term and short-term risks? But you can't package that into a 2-minute segment. So 65 years over or younger with chronic illness. Well, it's over 65, they're saying that basically you're not going to be eliciting your memory cells as robustly as when you're younger. That's true. That is true. All right. But you may be also increasing your chances of vaccine injury in an older stage of life. My take on this is that it really depends on the patient's particular medical history and medical situation. But in the aggregate, I think not taking vaccines, the messenger RNA, is prudent. In rare cases, it may be prudent to take. But it depends patient to patient, situation to situation, and it's not a cookie cutter issue. But if an individual already has antibodies for however they got them, I think that it lowers the chances that you need lowers the chances that you need the booster or some sort of updated version of the inoculant.
And have some chronic illness. Well, that makes me worry. I think if that goes through and people don't get vaccines, we're gonna see a whole lot more of COVID going around this year, Mark. I worry about that quite a bit.
Me too. I don't want to get it again, and I would be happily vaccinated. All right. Thank you, Dr. Witter, as always. Appreciate your time and your expertise.
But he has antibodies. So why is he worried? You get it. But the thing is that pulse. See, again, no matter what you do, you're trapped. If you get pulsed and you catch it, then you're hurting, you're revving up more of the IgG4s. You have more S1 subunit that could inhibit the TCR on the CD4, so your effective CD4 count goes down. But if you take a vaccine to try to fight it, guess what? You got the same problem. You're bringing up your IgG4s, the S1 subunit that's for the epitope for the vaccine ends up inhibiting your CD4 count temporarily or long term, depending on the situation. You're increasing vascular issues. You're increasing genomic integration because of the plasmid. Well, why doesn't this doctor say, hey, you know what? There's a manufacturing problem with the messenger RNA. Every time you get a booster, every time you get a vaccine, you're increasing your chances of having vaccine injury from the plasmids. It's better to actually just get the virus and just hope for the best.
Watch how butter affects muffin tops.
The reason butter is called butter is because of the butyric acid. The best part of GETTR is most people don't know that
Okay, let's listen to, this is about Hochul and her executive order about COVID vaccines.
There's a new front in the battle over COVID vaccines. Governor Hochul now says that she's going to sign an executive order allowing New Yorkers to get one at pharmacies without a doctor's prescription. The CDC just limited who can get a shot this year. The latest controversial push from the Health Secretary, Robert Kennedy Jr., who spent a day on Capitol Hill getting grilled by both parties. Eyewitness News reporter Josh Eidinger following it all.
New Yorkers in search of a COVID vaccine got a reprieve tonight. Governor Hochul announcing she'll sign an executive order explicitly allowing pharmacists to prescribe and administer the shot after CVS and others said they'd require a prescription from a doctor.
I'm totally confused what I'm allowed to have and what I'm not allowed to have in terms of the injections. I have no idea.
That confusion follows a surprise decision by the Food and Drug Administration, authorizing the latest vaccine only for older Americans or those with underlying conditions. Healthcare chaos on full display today at the Capitol.
Do you accept the fact that 1 million Americans died from COVID? I don't know how many died. Do you think the vaccine did anything to prevent additional deaths? Again, I would like to see the data and talk about the data. You have had this job for 8 months and you don't know the data?
Health and Human Services Secretary Robert F. Kennedy Jr., a noted vaccine skeptic, faced a withering inquiry from the Senate Finance Committee.
I would say effectively we're denying people vaccine.
Senator Cottrell.
You're wrong.
Americans don't know who to rely on.
Most people already have antibodies. So what's the issue? The big problem is, what about the ones that are born after the crisis? And they don't have a natural infection. And they don't have a vaccine. They don't have antibodies. But they're young and they have a robust thymus and a robust immune system to weather it. So I think it's just don't vaccinate and just weather the storm. Now, that doesn't mean that there won't be viral infection harm on children. That doesn't mean that you won't have harm of geriatrics if they get an infection and they, because of their comorbidity, speeds up the death process. But by over-vaccinating, you're weakening the immune system. So if most people have antibodies, the only real group that you really need to worry about are the ones that have a really poor immune system, which there are some in that population, or the ones that are newborns. What do you do in those categories? And I think the ones that have a really poor immune system, especially if they're older and they have a comorbidity, it may actually be beneficial for them to take the inoculation. But it probably is better if they're sick and if they test early and they get treatment to use monoclonal antibodies. Monoclonals are amazing. All right. So the treatment may be the monoclonal. Now, for the youth, the young, that never had an inoculation, never had a viral infection of SARS-CoV-2, what do you do for that population? And if they have a robust immune system, just let them weather the storm. It may harm them, it may not, but it's less probability of harm. But if they have some of these children have different stages of immune system disorder, if they have that, then again, it's not about the inoculation, it's about the monoclonal if they're sick. So the actual solution to this is stop vaccinating for SARS-CoV-2. And if you have a patient, catch them early and give them the monoclonals, not a vaccine. And when they catch it, their body is fighting it, producing antibodies, and if they have that immune system issue, it may not be robust enough to be able to produce the antibodies, but you're checking the the infection by the monoclonals and clearing it. But in most cases, even with an immune system that's disrupted and it's weakened, by having an infection, you will eventually produce antibodies. Maybe not a high levels of titers, but you will eventually produce antibodies in most cases. There's some diseases where you don't have class switching and you have only IgMs and no IgGs, and there's lots of different issues, with, especially in pediatrics. But when you talk about the average person, they don't have this problem. So the average person is just better off just weathering the storm. But if they do have a problem with their immune system, monoclonals. If you're older and you can't elicit an immune response, monoclonals. So it's not so simple as these questions from the senators. How many people died during COVID? Well, about 1 million people died from COVID. But there were even more people that died from the aftershock of COVID. And that aftershock is long-term side effects of the viral infection or long-term side effects of vaccine injury. Now, that and that's not even, we don't even know the excess deaths from just long-term effects of COVID and or the vaccine. And that's way more than 1 million. That's in tens of millions. Tens of millions. Tens of millions of people have had problems because of the virus and or the vaccine. So I'll call it the COVID era, that died.
Republicans who voted so recently to confirm his appointment by President Trump now angry at Kennedy's ouster of his own CDC director, Dr. Susan Monterez, who wrote in the Wall Street Journal she'd been fired for refusing Kennedy's troubling directive that she rubber-stamped the as-yet unwritten recommendations of a panel she claimed that was filled with people who have publicly expressed anti-vaccine rhetoric.
I told her that she had to resign because I asked her, are you a trustworthy person? And she said no. So if you had an employee.
So you're saying she's lying?
Yes. Every conversation I had with her, they
And
were
we get
witnesses.
this straight, this is the same person that less than a month earlier, you stood next to her and described her as unimpeachable. And in a month, she became a liar?
When he appointed Kennedy to be his health secretary, President Trump said he'd let him go wild on health. Tonight, Trump said Kennedy did very well during his hearing today. Meanwhile, if you were confused about how to get a COVID shot in New York State, Governor Hochul is signing that executive order tomorrow, allowing you once again to go to a pharmacy without a prescription. In the newsroom, Josh Einiger, Channel 7, Eyewitness News.
Now, first of all, I think that's a bad idea with Hochul because the public should not be determining what they should be taking because they don't have the medical background. The other side of the coin is that there are many people within the medical community that have dogma and they're not paying attention to the data and not paying attention to, hey, there's vaccine injury, why? Now, people are diving into this and it's great that they are, and we're starting to notice that, guess what? The manufacturing process sucks for vaccines. There's plasmids, really bad. You want to affect tissues in a petri dish? What do you use? Plasmids. Do genetic mutation or gene expression to see if certain things happen to a cell. So if you're going to have a lot of plasmid concentrations in the vials, then you're going to have lots of plasmid concentrations in the syringe. You're going to have lots of plasmid concentrations in your in the extracellular matrix, in the interstitium. And eventually you're going to have higher concentrations of it in your cells. So don't be surprised that you have turbo cancers, because that's how you affect cells in the laboratory to get them go to cancer. You do knockouts and stuff by using plasmids. So it's a major problem. So one, people shouldn't be deciding if they should be getting a vaccine by themselves. It should be a prescription. But not just that, doctors should be starting to use some common sense and saying, you know what, well, wait a minute here. The antibodies that most people have are effective in an immune response to the new variants. Therefore, why do you need an updated one or a booster? Because most people have titers and most people have memory cells. So you have herd immunity. So why do you keep on doing this? It's a combination of dogma, not realizing that they're not paying attention to the science of immunology, and there's vaccinology, I guess is the term, but they believe in this dogma of vaccinology. And you have another group that knows that they can make money by doing this, either at the big pharma level or at the clinic level, at the insurance reimbursement level. And then you have another group of people that's even more nefarious, and that is the national security system. The national security state needs, this is part of the whole reason why I'm doing these videos on bioweapons in foreign policy. You have to have a mechanism to be able to put into human bodies a bioshield for weapons you're developing and weapons you think your adversary is developing, so your population is ready for war. And this is another reason why people need to look at this in the context of biowarfare and not in the context of vaccine or anti-vaccine. It's the wrong lens to look at this issue. And so the national security state is trying to create institutional buy-in, public buy-in, in getting their psychology to get a booster every year, get to the clinic every year and get your shot. And they are now creating a behavior where it's easy to inoculate the population for bioshield.
Let's count the smiles.
If you want.
Amazon Freight scales with you. Simple booking and 24/7 support. All powered by Amazon's network of smiles.
A new strain of COVID is spreading. The CDC says emergency room visits are up across all ages this summer. This new strain, called a Stratus, is proving to be slightly more contagious, but the cases are mild. Doctors say the reason for the uptick in cases is summer travel, and symptoms are mostly the same except for one.
The only symptom that is different is hoarseness. Folks are still coming in with cough, sore throat, shortness of breath, but that main distinction is the fact that they're coming in with a hoarse voice.
Health experts say getting vaccinated remains the best line of defense, but having immunity from a previous COVID infection won't have that layer of protection against this strain.
What? Wait a minute. Let's rewind that for a second. Let me make sure I heard that right.
In the defense, but having immunity from a
Sore throat, shortness of breath, but that main distinction is the fact that they're coming in with a hoarse voice.
Health experts say.
Wait. Now that's because there's a mutation on the spike that is attaching to the epithelial cells in your oropharynx. And this is why I keep on saying it's so important to keep that nice and healthy and, boost up that immune system. Super important. But okay, so the pathology is changing. This falls in line with it's tracking to other types of tissue. I predicted this 5 years ago. All right, it's happening now. Okay, now let's listen to what they're saying about Stratus and the immune system.
Getting vaccinated remains the best line of defense, but having immunity from a previous COVID infection won't have that layer of protection against this strain.
That's totally wrong. That is totally bullshit. That is totally bullshit. Because the epitope of Stratus is so similar to the S1, S2 subunit that most people have been exposed to either through the natural infection or through the inoculation, where your titers are going to cut this. And not just that, if it's not working as robustly, it's going to do two things. Your immune system will do two things. So you have titers that are going to block it. But let's just say it doesn't block it as efficiently. What's going to happen is it's going to elicit a response from your plasma cells, produce more antibodies to try to block it in, and it's going to break up and produce a presentation on the MHC of different proteins to elicit more antibodies to the natural infection. So not only will you have an S1, S2 subunit, let's say you never had SARS-CoV-2, in this case, in the case of a patient, never had SARS-CoV-2, now you get Stratus, but you've been inoculated, right? You had a vaccine. So that means you have an S1, S2 epitope, and you have antibodies for that. You have IgMs, you have IgGs. Now, those IgGs are going to attach to that virus, and let's just say it doesn't attach so well. All right? In that case, it's going to elicit more antibodies to be produced and activate your MHC2 pathway to elicit an immune response based on breaking up some of that virus and presenting those proteins to the immune system. So now you're going to be producing antibodies to the membrane, to the envelope, to the spike, to the NSPs, so different parts of the virus. So you're going to be even more robust in terms of a antibody profile against SARS-CoV-2. Now let's look at a case where a patient had SARS-CoV-2 in the early days, before Omicron, or even Omicron, doesn't matter, but let's just say before Omicron, and didn't have an inoculation. You catch Stratus, you have antibodies to the M protein, right? The S protein, you have these different antibodies. So even if the S1 or S2 is mutated in such a way where your antibodies against the S1 or S2 epitope from prior infection aren't as robust, chances are your other antibodies against the E or the NSPs are robust, because you have a more broad spectrum of antibodies to fight the virus, because your body has broken this thing up, not just the S1 and S2 subunit. So you're actually more protected against Stratus if you had a prior infection. So there is a concerted effort to get people to take vaccines. Now think about this. We're playing this this was 2 weeks ago, and we're also playing videos that were 3 or 4 days ago. Now what's happening in the news? There's a pushback from HHS, don't take messenger RNA. And now you have the media saying, take it. I'm telling you, do not get a SARS-CoV-2 booster or update. You don't need it. Don't need it. Okay. Let's see here. It's so sad to see that the battle is not about really the science. It's all about vax or anti-vax. And then they're trying to demonize Trump's administration because of the All right, let's listen into PBS NewsHour. This was 4 days ago.
Many Americans who want to get the newest COVID vaccines may now have a harder time doing so after the Food and Drug Administration limited approval for the shots to adults 65 and older or those who are at high risk for severe disease. The vaccine was previously available to anyone 6 months and older. People have questions, and we're going to try to answer some of them now with Caitlin Jettalina, adjunct professor at the Yale School of Public Health and the author of the Substack column, Your Local Epidemiologist. Welcome back to the NewsHour. Thanks for joining us.
Thanks for having me.
Let's just start with the basics here. Right now, according to the FDA, who is eligible to get the COVID-19 vaccine?
That's right. So FDA narrowed its label last week for COVID-19 vaccine to only people that are 65 and older and those 6 months through 64 years with at least one high-risk condition. This is a big departure from past years, and it is quite unusual for the FDA to restrict a vaccine this way. Meanwhile, medical groups don't necessarily agree with the FDA label. Pediatricians, for example, recommend all kids under 2 get vaccinated, whether they have a high-risk condition or not. Plus, high-risk kids and those living with vulnerable family members. And so as you can imagine, this is starting to get confusing pretty quickly because you can end up with scenarios where on one hand, pediatricians say a healthy 1-year-old should get a COVID vaccine this fall because of their little vulnerable immune systems. But on the other hand, FDA label says no. And so that means for some families, they could be pushed onto getting off-label COVID-19 vaccines this fall.
Just one more definitional question here. When you're talking about high risk, what are we talking about? What does that include?
Yeah, so FDA didn't spell this out last week, but they did defer to CDC's list. And this is good news because it's very broad. High risk includes everything from pregnancy to those with diabetes or obesity and cancer, disabilities, or even mental health conditions. And so by some estimates, that covers nearly 3/4 of US adults.
More vaccine injury is going to happen if they follow this. If the pediatricians keep on inoculating these patients at 1 year of age. Now the thing is that it takes around 6 months before a pediatric patient can start to elicit IgGs. So their immune system starts to get booted up at around age 6 months, around 6 months. So So you're increasing the chances of vaccine injury with these pediatric patients on top of the normal schedule. See, this is the part of the issue here is that should they be getting it at all? I think no. Why? Because the safety, is there some sort of efficacy of it? Yes, there is an efficacy of a vaccine producing antibodies to fight an infection. The problem is that the way these things are made, it's not safe. So it can cause other harms that may actually hurt the patient and weaken their immune system. So you have that problem. And then in the context of over scheduling vaccines in pediatrics, there is another layer of potential problems. So I would say no, do not vaccinate the child because of the potentiality of the vaccine injury. Now the question comes in is then the parent's going to go, well, I don't want them to have COVID because it can have all these problems. Well, like I said, you have to pick your poison. Which one is better? Which one's not? Can you get cancers from SARS-CoV-2? Yes. Can you get cancers from the vaccine? Yes. Can you get early onset of dementia from the SARS-CoV-2? Yes. Can you get cancer? Can you get early onset of dementia from the The inoculant? Yes. From the vaccine? Yes. All right. Can you have immune system problems from SARS-CoV-2? Yes. Can you get immune system problems from the vaccine? Yes. There's no solution to this. That's the problem. See, the doctors are only looking at the short-term effects. Can you reduce the severity of an infection? And the answer to that question in most cases is yes. If a vaccine will reduce the severity of most SARS-CoV-2 cases. That's a true statement. But they're not paying attention to what are the negative externalities downstream that may be even worse than a severe case of SARS-CoV-2. So the real battle here is what do you do with pediatrics that are coming into the world and they have never been exposed to SARS-CoV-2? What do you do? And my take is you don't do it. Let nature take its toll instead of constantly injecting patients with things that could do harm. But it's not an easy decision because harm could happen both ways, no matter what your decision is.
For trying to understand this change, I mean, you mentioned it's not typical for these kinds of policy changes to happen. There's disagreement in the medical community. What is your understanding of what led to the change? Did something change with the vaccines or COVID itself?
Yeah, so science hasn't changed, right? The vaccine is still effective at providing additional protection, and it's also safer than the virus itself. What has changed is, one, the environment, right? Most of us now have some level of immunity, and our ICUs aren't overflowing. We're not in the middle of an emergency, which is great. And so on one hand, it does make sense to prioritize pregnancy in kids under 2 and older adults, for example. But the way this policy is being rolled out, it's out of order, it's inconsistent, it's very unclear, it's not transparent, has left a lot of pharmacies and physicians and families scrambling, mainly because RFK, our Health and Human Services Secretary, doesn't believe that this process was evidence-based, although it's been the process we've used for the past 90 years.
So you mentioned the pharmacy piece of it there. People have probably seen both CVS and Walgreens are now limiting access to the COVID vaccine in some states, requiring prescriptions in others. If people want to get the shot, are they going to be able to get it through their local pharmacy, and is insurance going to cover it?
Yeah, this is like the billion-dollar question, right? And this is critical because 90% of COVID vaccines are given at pharmacies. So right now, 2 things are happening. One is in about 16 states, pharmacies like CVS or Walgreens have paused COVID-19 vaccines altogether because their state's authority depends on very clear guidance, which we haven't really gotten from CDC. We were supposed to get it in June. They still hasn't come out yet. So those states are in limbo. The second thing that's happening is that in other states, pharmacies may still offer the vaccine. They may still have them in stock, but for people who only fit the FDA label, pharmacists generally cannot give vaccines off label. So if you're a healthy 40-year-old who wants to get the shot, you'll probably be turned away from your pharmacy. Insurance coverage is also in limbo. It's not entirely clear whether health insurance is going to cover the cost of your vaccine, and this uncertainty makes it very difficult for families who want to protect themselves.
So a lot of questions we don't yet have the answers to, it seems like. But, you know, as you mentioned, pretty much anyone 6 months and over could get the shot before this policy change. But we should also point out uptick of the vaccine has been very low among adults. CDC data showed that less than a quarter of adults received the shot last year. So for most
people, part of the reason why we're seeing lower cases is because the immune systems aren't being downregulated by the overboosting at the societal level. See, if you have a lot of people overboosting and you have this S1 subunit inhibiting the TCR for the CD4, then if you have a society that's overboosting, you're going to have people's immune systems down, and then there's a surge of more COVID. Right? This is why I'm saying that people like her don't understand immunology. She's an epidemiologist, not an immunologist. So there's this overboosting that's weakening the societal level immune system, and there's a surge of cases. The reason why we have less cases is because we don't have that overboosting. All right? But the thing is you still have, because of the endemic phase of this, it can mutate and then surge up again. Like I said, it's like now evolution's finding a path to attach to certain tissues and to take hold in the human population. And this is Nimbus and Stratus, all right, that has evolved. But it's still locked in because so many people have antibodies. The same epitope from the inoculant, which I think was a bad idea to have the same epitope. And you have a broad spectrum of antibodies from people that have natural infection. So you have a decent level of herd immunity. But if you have a lot of people that are overboosting that shouldn't be taking boosters, or, you know, updated versions of the inoculant, if you have a lot of people doing that, the immune system at the societal level is going to go down. And the virus will find a way to start infecting more. It's just an evolutionary process. If you're trying to get an animal in a laboratory test to get sick, you want to weaken the immune system and get them sick. And then you treat them, you test to see if a certain therapy helps, right? So you have to weaken their immune system. You have to break tolerance. You have to, right? Well, that's what happens when you keep on overboosting. To break tolerance in an animal for animal testing, you keep on issuing a particular substance with an adjuvant. And you just keep, you're trying to break the tolerance, and then you cause the disease. This is what they're doing to us. And it's the people like her that don't see the dogma. Maybe because she never did animal testing. I don't know. But the thing is that if you have antibodies, you'll be able to weather the storm. The question is for ones that have really poor immune systems, ones that are older that can't get their memory cells activated, or they have very low titer levels and they just have a bad immune system. And the other side of the belt, the barbell distribution, is the young that have never seen SARS-CoV-2 because they're born. What do you do for those? Well, you don't do anything for the first 6 months for sure, right? But what do you do? What do you do for age 1 or 2 or 3? Should you be taking it with or without other vaccines? Should you even do it? Now, my take is natural infection is probably the best. It's the most broad spectrum. Now, if there's a certain case where their immune system is poor and it's not working, then you may need to do it. But most likely, monoclonals is the best solution if they catch it. But the thing is that there's no good solution here. But overboosting, so we have low take rate of SARS-CoV-2, low take rate, and low cases, because the immune system is starting to heal now. And it's not down-regulated by an overproduction of IgG4s. So when you have more effective CD4s, your immune system is more robust. But if you have a big surge of the population that's going inoculate, 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 and this is part of the reason why, if you take a look at the epidemiology curve, why is it that after a month and a half or 2 months, you started to see anywhere from a month and a half to 2.5 months? But it was latent. You take what would happen is that there would be a big surge of population getting vaccines, and then all of a sudden another wave of SARS-CoV-2. And it's not because the inoculant gave SARS-CoV-2. No, you're missing the point. The inoculant weakened your immune system so you'd be more susceptible to SARS-CoV-2.
Original shots, if you got some boosters, if you've had COVID, should they still be getting the COVID vaccine?
Absolutely not.
What we're saying is that the data is consistent, that if you get a COVID-19 vaccine, you have additional protection against COVID infection, albeit not perfect, but also severe disease. For at least 4.
You have titers for 10 years. For 10 years. You have memory cells. So even if you get it after 10 years, your memory cells will activate within 14 days. Now, chances are, if your titer levels are, really low on the 9th or 10th year and you get SARS-CoV-2, it may be more severe than if you received it in the 5-year mark. That's true. But the thing is your body will elicit a response. And not only that, you have a broad spectrum of antibodies. So it's not just the epitope that's in the inoculant. We're not in the 10-year mark yet. We're in the 5-year mark where most people's antibodies or most people's titer levels are at the highest level.
Six months after the vaccine. It is getting really confusing. For my family,
Wait. Let's roll this back. This woman's fucking bullshit. Just total bullshit. Total bullshit. All right, let's rewind a little bit and then listen very carefully to what she has to say.
From your pharmacy. Insurance coverage is also in limbo. It's not entirely clear whether health insurance is going to cover the cost of your vaccine, and this uncertainty makes it very difficult for families who want to protect themselves.
So a lot of questions we don't yet have the answers to, it seems like. But, as you mentioned, pretty much anyone 6 months and over could get the shot before this policy change. But we also point out uptick of the vaccine has been very low among adults. CDC data showed that less than a quarter of adults received the shot last year. So for most people, if you have—
And those quarter of the people are weakening their immune system. But because there's not enough of them doing it, it's the cases of SARS-CoV-2 are suppressed. Okay, now let's continue.
If you got some boosters, if you've had COVID, should they still be getting the COVID vaccine?
What we're saying is that the data is consistent, that if you get a COVID-19 vaccine, you have additional protection against COVID infection, albeit not perfect, but also severe disease, for at least 4 to 6 months after the vaccine.
But she doesn't tell you, and I've been saying this I did a big show with Mike Adams about this. Your titer levels become non-responsive and the max level of the titer from the booster starts to go down. So you have a slow, non-responsive situation that the more boosters you have, you're actually suppressing your immune system. You're suppressing your immune system in terms of responsiveness to bring up the titer level, and you're suppressing your CD4s because of the S1 subunit attaching to the TCR. Now, so they're saying, well, wait a minute, think about how it normally works. You get a vaccine, it lasts for 10 years. You have memory cells. So if you catch it, even at the tail end of those 10 years, you can elicit antibodies from your plasma cells. So the severity, within the 10 years, the probability of a severe infection is low. The probability of having a more problematic infection is higher after 10 years, but you have about a 14-day situation, 17 to 14-day situation to elicit more antibodies from the plasmids once you get infected, let's say in year 11, year 12. All right, so the infection may be a little bit more severe because you don't have as many titers. All right, but you haven't suppressed your immune system by trying to boost your damn titer level every fucking year. Now, here, she's even admitting it, but she doesn't even realize how she's admitting it. She doesn't understand what I'm saying. Absolutely not. 4 to 6 months after the vaccine. Remember how it's supposed to work, 10 years. But if you keep on boosting, you are affecting your titer level. You become non-responsive. And you're affecting your CD4 count. This is the point I'm making. They keep on telling you have to reboost because they fucked up your immune system. Don't get it.
Confusing. For my family, I'm going to still follow the evidence-based guidance for medical societies. I am young, but I also have a chronic condition, so I will still be getting this vaccine this fall. Also, the vaccines aren't the only tool we have in our tool belt. I'm sure people are really sick of the Swiss cheese model, but there's also other steps to take not to get sick, like wearing a mask in private indoor spaces, testing before you visit grandparents in the nursing home. There's many ways to balance risk at this moment.
If I ask you to take kind of step back and look at the bigger picture right now, we saw last week Health and Human Services Secretary.
If you have a chronic condition and you keep on boosting, don't you think that you may be making it worse by shutting down your immune system? Now, what if you have a chronic condition that's tied to an immune system issue? That's a different situation. And your best bet in that case is that if you have a bad immune system and you're trying to elicit a response, most likely you probably don't want to take the vaccine. You probably want to leverage monoclonals if you take it right away once you contract. I'm telling you, people, if they buy into what she said and the masses do it, you're weakening your immune system and you're going to make things worse. The way to do this is to weather the storm naturally. And that way, you're going to have more types of antibodies in the population, and it will suppress it because you have different types of antibodies against M, against the NSPs, against the S proteins, instead of just the S protein. Would you go into battle with just a tank? Or would you go into battle with, Air Force and lasers from space, infantry, a broad spectrum of military hardware? Of course you would do that. But they want you to just go into battle with just the epitope from a vaccine. If you have had an infection, if you have had an inoculation, it lasts for 10 years, the titers. You don't need a booster. You don't need an update. It's a fallacy. The problem comes in is the debate on people that are born after COVID. What do you do? Now, my take on it is let them get the natural infection. But to realize I'm not pro-vax and I'm not anti-vax, but to realize that vaccines can harm, overboosting definitely harms even more. Getting COVID could harm. And if you get COVID multiple times, you're increasing the chances of a lot of bad stuff. Accelerated cancers, dementia, autoimmune diseases, AIDS-like syndrome, long COVID, lots of bad problems can happen. Amyloidosis. So there's no good solution here. What's the best bad solution? And the best bad solution is just to take the hit. and not getting the natural infection and not over boosting. What's the worst solution? The worst solution is over boosting. That is the worst solution. The bad solution, getting the natural infection. But there's no good solution to this. There will never be a good solution to this.
Kennedy Jr. fired the CDC director, Dr. Susan Minares, that also then led to the resignation of multiple other senior CDC officials who all said they were concerned about his leadership, concerned about his stance on vaccines. I just want to get your response to that as someone who tracks this very closely. What are your concerns, and are you worried about the CDC losing its credibility in this moment?
Last week was a huge week in public health because essentially CDC imploded, right? Like you said, the director and 4 senior leaders were pushed out. And these aren't not just bureaucrats. There was very steady hands who guided us through crises after crises with clarity, compassion, and were evidence informed. And when leaders like this are forced out,
evidence informed. The CDC during COVID never mentioned that they have SV40 high concentrations of plasmids in the messenger RNA. So people were making decisions with not a full understanding of what the facts were. And by the way, Pfizer was trying to hide it. Then you get into this whole thing. It's like, well, wait a minute. Where did SARS-CoV-2 come from? These same people that are evidence-based, still believing that vaccines are great, not paying attention to the real information, like why is there vaccine injury and what the hell is going on with the vials and what's those concentrations that shouldn't be so high? They don't ask the real question, like, where did SARS-CoV-2 come from? Oh, it must have been zoonotic, because that's where all of them come from. Well, what about a weapons program? What about the national security state making stuff they shouldn't be making? Isn't it really odd that there's all these different NIH grants going into Barrick's lab? Isn't it odd that there was a conduit through EcoHealth Alliance and the NIH into Wuhan in enhancing this virus? So how was it zoonotic? All the data is showing otherwise. We even have checks that were cashed by Barrick for his research to make SARS-CoV-2. Oh, it even goes back to 2001 for SARS-CoV-1. It wasn't even called SARS-CoV-1 back then. But he made that too with an NIH grant. Evidence-based. Evidence-based. No, what it is you have the medical community dogma not paying attention, and they got their head up their fucking ass because they don't want to make the realization that there is a weapons program that was developed. And there was a bioshield that didn't work. And there's no good solution now because mankind did things that they shouldn't have been doing. So the only thing that you can solve this problem isn't more therapeutics, more vaccines. The only way to solve this problem is hope for the best and weather the storm. There's no other solution.
not just the agency that suffers, it is all of us, right? A weaker CDC means communities are more vulnerable from outbreaks to chronic disease.
Oh, that's so parochial. The CDC was one of the conduits of the national security state to create the guidelines for the bioshield, for biowarfare. Now, of course, they have other responsibilities, like trying to prevent measles and polio and all this other stuff. But the CDC has many problems. One, many of the people are captured. They're on the take. They want their golden parachute. The revolving door. You can see the revolving door right here. Going to big pharma for the big pay packages. Is it evidence-based or is it money-based? Is it national security-based? And this is where people need to start paying attention. And this is where the anti-vaxxers start to just not pay attention to the big picture. It's not about the vaccine injury. It's about bio-warfare. And will a society be able to weather a storm with a biological warfare with China? What are you going to do? What are you going to do, anti-vaxxer, when China releases a pathogen? What are you going to do if the United States decides that we're going to release biological warfare against an enemy? What are you going to do? What are you going to do? You're not in a power of control. You're trapped. Everyone is trapped with this. There's no good bioshield, because what DARPA thought was going to be the bioshield was the messenger RNA platform. That was the quickest, but guess what? It's not the safest because of the way it's manufactured. It is the quickest, but it's not the safest.
This to even basic health data. The foundation of public health is eroding faster than I ever thought possible. And I don't say this lightly, but if we do not change
we should have a population being negative to the CDC, because the CDC has been pushing a dogma and harming and not paying attention to those injuries and finding the root cause. Instead, they're saying that it doesn't exist or demonizing people that are looking into and researching it. It's a dogma on top of a revolving door for a golden parachute with big pharma. There's lots of money to be made in this with the pharma lobbying group. Lots of senators are on the take too. And then you add in the national security state dimension to this, where how do you administer a bioshield to the mass public if you're in a biological warfare, or you're going to launch a biological warfare? How do you prep your society if you're going to release a bioagent against your enemy? You're going to have to use the CDC as part of the conduit. Come on, wake up. Get into the 21st century. We're in biowarfare now. Wake up. Wake up.
I truly think our nation's health security is at risk.
Caitlin Jetelina, author of the Substack column, Your Local Epidemiologist. Always good to speak with you. Thank you.
Thanks for having me.
About 40% of adults say that they are likely to get the COVID-19 vaccine this fall. Hopefully that number is a lot less, because the higher that number, the more chance of cases going up. Because of the non-responsiveness with the titers and the weakening of the CD4s. I'm telling you, this is a bad idea. And where are the doctors? Where are the doctors that are out there trying to warn the public? There are very few of them out there. And it's not, again, there's another dimension to this. Biowarfare. What do you do? Just put on the biowarfare hat. If you have your military having capability to use biological weapons to hurt your enemy, how do you create the bioshield for your population so there isn't a negative externality with the feedback loop? What do you do? Come on, anti-vaxxer, what do you do? Wake up. But it's the same problem. What about the pro-vaxxer? See, the problem is the pro-vaxxer and anti-vaxxer are the same, they have the same stupidity. Pro-vaxxer, what are you going to do? What are you going to do when you have all these weapons being developed and it's released into the wild? Why did you prevent it? Pro-vaxxer, come on, pro-vaxxer, what are you going to do? Oh, we're just going to overboost. Well, wait a minute, that weakens the immune system. All right, that's enough of that. The key to this is that in the fall and in the winter, there's going to be higher cases. There will be even more cases above the natural trend if more adults get a booster. If you get more vaccines for SARS-CoV-2, if you get more of them, then the natural progression of the cases are going to go up in the fall and the winter. And when there's more cases, there's more probabilities of it spreading. Now, if someone said, Dr. Paul Cottrell, what do you suggest? I suggest making sure that you don't take any other vaccines for SARS-CoV-2. Don't take any of them. None. Zero. Now, that doesn't mean that you're going to weather the storm perfectly. You may get SARS-CoV-2, but most likely it will be mild. In some cases, it may be moderate, and in other cases, it may be severe. Some people will die from it. Most people won't. But you're just going to have to weather the storm. Because if you boost, you're going to make it worse. Not just for yourself, you're increasing the chances of making it worse for yourself, but you're also making it worse for the society because there's going to be more cases. Again, like what I said, if there's a large number of people taking the same epitope around a month and a half to 2.5 months, there's a spike of cases. And it's because the immune system is down. There's this dynamic that happens at the societal level. But, the dogma. You have all these doctors saying, well, wait a minute, we have higher cases, so we got to get a booster. Well, wait a minute. Wait. Memory cells, didn't they when they went to medical school, didn't they take an immunology class? When you get certified, you have to, show that you have knowledge of immunology. What about IgG4s? What about memory cells? What about T cells and B cells and CD4s and CD8s and antigen presenting cells? Natural killer cells. What about those? Come on, doc. Get with it. Please help support the work that I do. All these videos are for free. Hopefully you learned that there's going to be a problem in the fall and in the winter. It will be even worse if more people take these inoculants. So please make sure that you share the links, ask your social media to follow me, help support the work by donating on my website, the-studio-reykjavik.com. You can also be a paid member to my Patreon channel. You can be a paid member to my Substack. I put all these videos out for free because I think the information I have to say could save your life. And it's important that I don't put it behind a paywall, but I need your support. And by the way, if you listen to some of my other videos, I kind of tell you how to navigate through this. I can't say it in this video because of the censorship, but please pay attention. I will walk you through this. I'm telling you how I'm handling it, and my accuracy of dealing with this crisis is extremely high. So please pay attention to me. I'll get you through this. But you have to realize the ones that are pushing a certain dogma either don't know any better or on the take. So you have to pay attention to that. All right? There's a fundamental issue that they have with these over-inoculations, and that is they're not paying attention to the 10-year titer levels, and they're not paying attention to the memory cells. That they assume you don't have memory cells. Why do they assume that? Why do they assume that? But yet you do have memory cells. So it's really important to just step back and go well, wait a minute, does it really make sense? Now people would say, why do they have always a annual booster for influenza? Well, influenza virus, but it's a different type of virus. It's a segmented genome virus with different genomic reassortments. You can have genetic drift and genetic shift. So The big problems with influenza isn't so much the drift, it's the shift when these segmented genomes switch over. And this is why it's like H5N1 or H5N5, and right, so you have these shifts between the H and the N. So it's a segmented genome. SARS-CoV-2 is not a segmented genome. So you don't have genetic shift. So don't fall into the dogma. Please go to my website, the-studio-reykjavik.com, and take a look at the great products that I offer. Thank you for listening and have a nice day.